This video will discuss the present value of an annuity. The present value of an annuity is the amount needed today in order to fund all payments of the annuity. So we're going to find the lump sum, or the amount needed today to deposit into an account that will give us a value that we need in the future. You save $500 each month for 9 years. Assume your savings earns 1.5% compounded monthly. Find the present value. In order to solve this problem, we're going to use the present value of an annuity formula. So this formula is on the screen, and it looks a little complicated, but we'll just take it step by step. And the first step is to identify the values for P, which is the amount of each annuity payment, I, which is the interest rate per compounding period, and N, which is the total number of compounding periods. So P is given to us in the problem, and that's $500. I is found by taking the interest rate, which is 1.5%, and remember we want to write percents as decimals, so 1.5 divided by 100 will give us a decimal of 0.015. And we want to take that decimal and divide it by the number of times the deposit is compounded a year, which is monthly, so we'll divide by 12. 0.015 divided by 12 is 0.00125. N is the total number of compounding periods. So we're compounding monthly, so I need to multiply 12 by the number of years, which is 9. And 12 times 9 is 108. We're going to take these values and substitute them into the formula for present value of an annuity. So here we took the values for P, I, and N and plugged them into the formula. Now, when solving this formula, we want to work from the inside out. So we're going to look for the parentheses that are on the very inside of the formula and then keep on working the parentheses outward. So my innermost parentheses are here. So I'm going to add 1 plus 0.00125 together. And I get 1.00125. Now I'm still working on that same parentheses because I want to take that value and raise it to the 108th power. When we do that, we'll get a decimal of 1.144440299. Next, we're going to do 1 divided by that number. So notice now we're working within these parentheses. When you divide, you get 0.8737895,728. Now, you're going to want to write each of these steps out on paper because you have to do 1 minus that decimal next. So you'll need to put 1 in your calculator, then the subtraction button, then you'll have to type out that decimal to get your new answer. And remember to always keep your decimals as long as possible. As long as you go step by step and write everything out nice and neat, this should come out correctly. So 1 minus that decimal will give you a value of 0.1262104272. And then you're going to divide by 0.00125. Now you can keep that number in your calculator and put the division sign and then 0.00125. And you should get 100.9683418. When you multiply those two values together, we should get that our present value is $50,484.17. And remember to round to 2 decimal places. And that is the final answer. Find the lump sum that must be set aside today to make semi-annual payments of $1,200 for 14 years. Assume 8% interest compounded semi-annually. So whenever we're asked to find the lump sum needed today, that means we're going to use the present value of annuity formula. So this is the same formula that we used before. We're just going to practice with new principal amounts, interest rates, and total of compounding periods. So first we want to identify those values. P is going to be $1,200. I is the interest rate, which is 0.08. That's written as a decimal, and we're going to divide by 2 since it's compounded semi-annually. When you do that, you get a value of 0.04. N is the total number of compounding periods, so we're going to multiply 2 to represent semi-annually by the number of years, which is 14, and that gives us a value of 28. Now we'll just plug those values into the formula and solve. So as a review, we're going to plug those values in and work from the inside parentheses out. So first we'll add 1 plus 0.04 and you get 1.04. Next, we'll raise 1.04 to the 28th power. You should get a decimal of 2.998703319. And write that number down on paper and then clear your calculator. And then on your calculator, you'll do 1 divided by 2.998703319. Once you do that division, you should get a decimal of 0.33347747713. So you'll write that number down on paper, and then you'll clear your calculator again, and you'll do 1 minus, and you'll type in 0.33347747713 and hit equals. All right, so now we have a value of 0.66652252287. And we can keep that in our calculator and then push the division sign and divide by 0.04 to get our next value. And that value is 16.66306,322. Then you'll hit the multiplication sign and multiply by 1,200, and we'll get a final value of $19,995.68. And remember to round to 2 decimal places. And that is our present value, or the lump sum needed today.